Okay. When an object is dropped, its speed continually increases, and therefore its height above the ground decreases at a faster and faster rate. Well, that probably doesn't make too much sense to you, right? By the way, this first paragraph here, it's just information. It's not even part of the problem. Okay, it's just telling you, giving you a little information what's going on. So if I have my axis here, my height and my time, here's my height and here's my time. Okay, we have this object being dropped. So I got this object being dropped and then it hits the ground, right? So what this is saying is, as its speed is continually increasing, so this speed is getting faster and faster and faster, right? Because of gravity. So the speed here, as the speed is increasing, I will not hesitate to bring in a big hammer and smash phones. As the speed is increasing, its height is decreasing. Not only is it decreasing, but as the speed increases, the height is decreasing faster and faster, right? Oops, spelled it wrong. Faster. So that's what that is saying. As the speed is increasing, the speed of the height that it's decreasing is getting faster and faster. Make sense? Okay. The height of the object after t6 seconds after it's dropped can be modeled by the function, and we've used this function a couple times. H equals negative 16t squared plus h of 0, where the h of 0 is the initial height, right? That negative 16 is gravity constant. Okay. Obviously, this only works on Earth because Earth is the only planet that has gravity that we know of. I think. I don't know. I'm not an expert on physics.
Planets have some sort of gravity.
Do they?
It's not true. Yes.
I don't know.
No. Everything has gravity. Otherwise, if you jump on like the moon, you just only Earth and the moon have gravity.
I don't know. I wish I knew. I really want to take a physics course. All right, let's do the actual problem now. A stuntman working on the set of a movie is to fall out a window 100 feet above the ground. So let's go ahead and draw a picture. That's not safe. I know students that have done that in the winter. Okay, so I got my height, got my time. Let's see, fall out 100 feet. By the way, what is that? What does that represent, the 100 feet? That's our initial height, right? So 100 feet here. So he's going to jump out of this window for a movie, right? Well, let's keep going here. For the stuntman's safety, an air cushion 26 feet wide by 30 feet long by 9 feet high is positioned on the ground below the window. So since we're in 2 dimensions, we really don't care about the 26 length and the width, but we do care about the height because I have a height axis. So it's going to be 9 feet, right? I'm going to move my ground up 9 feet because that's where he's actually going to land. So he's going to fall out of this window and land 9 feet from the ground. So there's my picture. Okay, for how many seconds will the stuntman fall before hitting the cushion? So we're looking for T, right, when he hits this cushion. Okay, again, here's our formula. H equals negative 16t squared plus h of 0. All right, let's plug in what we have. Now, his current height after he jumps out of the window is going to be 9 feet, right? So capital H is going to be 9. I'm not changing the force of gravity, right? Unless we go to the moon or something. So that stays the same, negative 16. My t, that's what we're solving for, right? The time. But we do know the initial height, which is 100. And since we had so much fun solving quadratic equations by square rooting, let's do it that way. So I'm going to subtract, I got to get t squared by itself, right? So I'm going to subtract 100 from both sides. I get 9 minus 100 is negative 91, good. This goes away, so I got negative 16t squared. And I'm going to put it up here. Negative 91 equals negative 16t squared. Got to get t squared by itself. So I'm going to divide by the coefficient, negative 16. Negative 91. Let's see. Negative 91 divided by negative 16 is positive 5.6875. So positive 5.6875 equals t squared. Okay, I got to get rid of the power 2, right? So I'm going to take the square root of both sides. That gets rid of the power 2. So I got my t, right? Now don't forget I got a plus or minus here, right? So let's go ahead and, because this is a word problem, I'm going to go ahead and get a decimal approximation for this. Okay. So I got the square root of 5.6875. And that's going to be about 2.38 seconds. Now, it should be a plus or minus, right? But because I'm working with time in a word problem, can I have negative time? Nope. So there's my answer. About 2.38 seconds. I should write down my label there. Seconds. That's it. I answered that question. For how many seconds? 2.38 seconds. All right, B, a movie camera operating at a speed of 254 frames per second records the fall. How many frames of film show the stuntman falling? Okay, I know I'm at a rate, I used what? 2.38 seconds, right? I'm going to multiply that by 254 frames per second. Frames per second. Okay, I'm going to put this over 1 because we have a fraction here. And what happens to my seconds, my labels, they cancel out. One on top, one on bottom, right? So I get, let's say I'm going to take 2.38 times 254. So I'm going to use about 605 frames. We should use approximation, which is a squiggly equal sign, right? Approximately 605 frames. Okay? So that's how many frames that we're going to have for the film of him falling. All right, one more. Now this one's actually pretty interesting. Problem. Use the falling object model h equals negative 16 t squared plus s, where t is measured in seconds and h is measured in feet to find the time required for an object that is dropped from a height of s equal 100 and s equal 200. So those are our initial heights, right? 100 and 200. Now this is what's really kind of interesting. Does an object that is dropped from twice as high, because this one's at 100, this one is at 200, right? Is an object take twice as long to reach the ground? What do you think? You guys tell me. Think about what's going on here. Okay, here's my height. Here's my time. So I'm going to throw one at 100 feet. And then one at 200 feet, right? Think about this. Is this one being thrown at 200 feet, is that going to take twice as long as the one at 100 feet? Go ahead, guess. Go ahead, guess. Yes or no? You got a 50-50 shot.
Yeah.
No? Yes?
All objects fall at the same
Huh?
time. In physics, it's all objects fall at the same time no matter like their weight, unless there's no air resistant or.
Yeah, we're assuming there's no air resistance, right? So are you saying that these will fall twice as long? It will take twice as long?
I think it could be the same time.
Think about what's happening, though. Remember, go back to the beginning here. The speed is not constant, right? It increases. So does the decreasing of the height also increases, gets faster. So now let me ask you, do you think, and I know what you're saying about terminal velocity, eventually these will be the same speed because it just won't go any faster. Every object has terminal velocity. If you drop it from 1,000 feet and 200 feet, if the 200 feet reaches terminal velocity, it'll be the same speed as that 1,000-foot one. Eventually. So this is actually a really good question. It gets you thinking. And like I said, I wish I took physics, and if I wasn't so old, I'd probably do it. All right, so we have two equations to solve. We can actually figure this out, right? We have the h negative 16t squared plus h of 0, right? Then we got this one. I'm going to go ahead and put the numbers in. So the ground is 0, right? Negative 16t squared. This one's going to be plus 200. This one's going to be the same thing, but plus 100. So let's solve these and see if the times, if it's actually double. It's not that bad of a problem. So I'm going to subtract 100 subtract 100. So I get negative 100 equals negative 16t squared. Then I'm going to divide by negative 16, right? Um, 100 divided by 16. Let's see here. Negative 100 divided by negative 16. It's positive 625. Now I have to take the square root of both sides, right? And again, I'm not going to worry about the negative here because we're talking about time. I just want the positive. So I'm going to do second squared to get my square root, 6.25, enter. So it's 2.5 seconds. Okay. All right, let's do 200 and see if it's double. All right, subtract 200. Subtract 200. So I'm going to get negative 200 equals negative 16t squared. Divide by negative 16. Let's see. Negative 200 divided by negative 16. So I get 12.5 equals t squared. Take the square root. And again, not going to worry about the negative since we're talking time. So square root 12.5. And I get 3.54. So is it double? No, it's not. It's double. So, I mean, you can make some conclusions about this, right? They didn't have enough time, both of them, to at least the 100 feet to reach terminal velocity, right? So they're at different speeds when they hit the ground. This one actually increased its speed for a longer period of time. That's why it's not double. Don't you find that fascinating? All that math to prove it. We proved it by using math. A real world problem. You guys don't seem to get so excited as I do.